Hi, this video is HL7 FHIR extensions and profiling, and my name is Terry Sippel-Schmidt. Before we jump into FHIR, I want to touch on what is profiling across all industries, not just healthcare. I pulled this off of the web, and this is how they define data profiling. Data processing and analysis cannot happen without data profiling. So that's a pretty strong statement. Data processing and analysis cannot happen without data profiling first. And data profiling is defined as reviewing the source data for content and quality. So they say that data profiling is content and quality. I would argue that content produces quality. As data gets bigger and infrastructure moves into the cloud, data profiling is increasingly important. And I would argue that that's nowhere as true as healthcare. Let's go take a look at a FHIR resource. This is the patient resource that you're pretty familiar with at this point. One of the things that profiling is going to look at first is cardinality, which is data, whether or not the data is required, and additional constraints. Now, if you recall, FHIR serves many purposes, and it is available to use with almost any clinical use case. So to get that ubiquitous usability, there are very few things which are actually required in HL7 FHIR. If you take a look at the cardinality column, which is a one in the first number would mean that it's required, at least one version of it. There's virtually nothing required in a patient resource. And while that's very flexible, it doesn't work for interoperability. Flexibility often is actually at odds with interoperability. So here we have our patient resource. We're looking at the cardinality, but we can also look at the description and constraints. We cannot change the description, absolutely cannot change the description of any existing element over here. However, we can add additional constraints. So for example, here we have gender, and we cannot change the definition of gender, but for some countries will actually have a different list of standard coded values. They can add to that list of coded values as it exists today. Let's go take a look at some more things. So we don't want to constrain our FHIR resource. Maybe we want to extend our FHIR resource. There's a library which is maintained within HL7 FHIR for every resource which has recognized extensions per resource. So here again, we're looking at the patient extensions within FHIR. Here's a list. So you can see that there's all different sources. This list keeps going for the patient one especially. There's a whole list of different elements which did not make the 80-20 cut. So the 80-20 cut is things that are going to be used 80% of the time. The other 20% are definitely exist and they get used, but perhaps they don't go into the base definition of a FHIR resource. One example, you'll notice that first of all, they all begin with the word patient, which is the name of the resource, all in lowercase, all appended with a dash, and then the name of the element. So as an example, you want to know where the patient location was, where your patient was born. Maybe for your particular use case, that's something that's very important. Okay, you could make it patient-birth location. But FHIR already has this extension library and they have patient birthplace. So I would argue that you never change, you never add a attribute or an element which has already been defined in the extension library. If it's defined in the extension library, you use the one that already exists. Okay, so profiling. First, you start out with what is the use case. Once you have your use case defined, you start to look at the HL7 standard itself. Which of the several FHIR resources, singular or plural, are you going to use to fit your particular use case? Within the FHIR resource, which elements are going to use? Are you going to change the cardinality or whether or not they're required? Are you going to change the defined values? Are you going to extend the defined values? Are you going to constrain the defined values? Are you going to add additional elements? Are you going to say that certain elements may not be used? All of these things can be done within a profile. There's the concept of a data type for an element called a codable concept data type, which means it could be a coded value or it could be text. Perhaps if you want to be able to search on your parameter or you search on your coded value, you will say not only is it going to be a coded value, but you're going to use a certain terminology set. You're going to say, I'm going to use LINQ. I'm going to use SNOMED. I'm going to use CPT4, ICD-9, ICD-10. So you'll define which code system And you'll define the code value, and usually you're also going to define the units of measure. And so that's another thing that you could add to your FHIR profiling, depending on what your use case is. If you're looking at a lab value, chances are you're looking at terminology with a code value and units. In addition to those, we can talk about API features. Many of the search parameters within FHIR are optional. Pretty much all of FHIR is optional. We can say that if you are going to support this particular profile, you must be able to use these search parameters, perhaps even with extensions or restrictions, and define certain behavior. Finally, as part of the profile, you can add additional clarifications and expected actions for when the resource or your particular use case is complete. Let's go take a look. Within HL7 FHIR, there's a registry of profiles. The US core set of profiles is one of the ones that is probably used the most often. This was developed through the Office of the National Coordinator, which is part of Health and Human Services. This was part of the HITECH Act. There's a long list of US core profiles. This is only a partial list. In this particular instance, they're organized alphabetically. If you go ahead and you click on any one of these, and they're all open and free and accessible, it will begin with a narrative text. And the narrative text begins to tell you how the US core changes the FHIR base resource. So I selected patient again, just because it's one that everyone's familiar with. And it says that a patient must have a patient identifier or medical record number, a patient name, and a gender, the asterisk means as defined. Now, this is interesting because if a patient comes in through ED and perhaps the patient or the person was out jogging, perhaps the person was a homeless patient, or whatever the case may be, they didn't have any identification on them. You may not know their patient identifier. You may not know their patient name. In that case, there's typically a way to set up a temporary system. There's typically a temporary assigning authority, which is a different OID. Remember the system or the OID that defines the namespace for who defines the medical record number. And there's typically a set of separate medical record numbers. And usually they'll have a prefix associated with them so that you know that this is a temporary medical record number. And it will usually get merged into a regular patient resource later when that becomes apparent. And that's the status, by the way, of the patient. And then you actually set the active attribute to false once it's been merged. Patient name, there's typically a way to assign different patient names for a temporary status. But you have to put something into those fields because if you're going to be able to comply with the US core, you have to be able to put some type of data. So you have to have a plan on how you're going to handle these kinds of situations. Now, each patient must also support both on the client side and the server side. So on the client side, you must have a way to input the contact detail, either as a phone number or an email address. You have to have a way to input on your client form, if you're creating a new patient resource, a birth date and address, a communication language, race, ethnicity, and birth sex. On the server side, you must be able to store all of this information. And then in addition to that, there's some particular parameters on how you query them. So let's go take a look at this. All right. Now we're looking, you'll notice at the HL7 FHIR standard itself, and we're looking at the US core and the structured definition. One thing I want to point out very briefly, because this causes a lot of confusion, is that in this yellow bar, you'll notice that it says it's version 3, standard for trial use, version 3. It's not final. That is referring to the implementation guide. So this page that we're looking at is the implementation guide, or a human readable version of the profile. This profile is based on FHIR R4. We always want to make sure that we're working right now. Maybe in the future it'll be R5, but right now we want to make sure that we're working with FHIR R4. So let's go down a bit. It begins with example use cases. Query for patient demographic using medical record number. Query for patient demographic information using first name, last name, date of birth, and gender. So it's a pretty narrow use case that this particular profile gets used for. We already discussed the specifications for the elements, and I'm going to scroll down a bit further. We're going to jump into the example structure definition. Okay. You can see that this looks like what you're used to looking at. when it comes to the structured definition of the patient resource. But you can see that there's a couple differences. Here we have extensions. We have an extension called US Core Race, US Core Ethnicity, and US Core Birth Sex. Furthermore, if I jump over to the cardinality column, you can see that things that were all zeros or not required as part of the base resource in FHIR are now required, and that's indicated by the 1. Not only is it required, so you can have multiple identifiers. You must have one. You can have an infinite number of identifiers, but for each identifier, you must have an assigning authority or a namespace, and you must have a value. So they're saying we don't want a database full of patients which do not have medical record numbers or some type of assigning authority. Furthermore, because this is now one-to-many, this patient must have a patient name. Now, as we discussed earlier, that the patient name can be absent and that there's a data absent reason, but usually what they're going to do is they're going to assign a temporary methodology for assigning a temporary patient name. They must have some type of system as well as a value for a contact information. So if they have contact information, it must describe what kind of contact information it is and then also have the value. You'll notice gender is now required. Over here on this side, I'm going to scroll down and show you one more because it's kind of interesting. Over here in the address, you can see that now postal code has a binding to US zip codes. So up in Canada, you'll probably take this binding off. Now, in addition to some extensions, some changes in the cardinality, we also have over here in constraints, we have additional bindings and where it will say things, for example, US Core 8, which you can look up US Core 8, and it will tell you exactly how patient name needs to be formatted. Another binding is administrative sex. Another binding, as I mentioned earlier, is US zip codes. So you can see how additional constraints have been added and they're highlighted throughout the constraint category. So what I should have mentioned a bit earlier probably is the tabs across the top you'll notice are different. This is the differential view, which is the default. However, there's also a text summary view. Personally, I'm not a fan of this representation, but you can see that you can read the entire profile, the entire resource in text. I think that it's clear to read the differential view. But you want to know, this isn't just what's changed. What does the entire resource look like? Well, we can go over to full view. Full view contains everything that a patient resource based on the base standard FHIR definition of the resource plus the profile now contains. So for example, here's our patient resource. Here's our logical identifier, which is our 64-digit ugly character. Here's the language of the resource. Here's the text, which we'll come back to later. This came up last week. Look, here are our extensions based on US core elements. These are the extended elements. You'll notice over here. So over here, we come over to identifier. Now you'll notice that the cardinality has changed. So this full view will give you the entire resource, including all of the changes based on US core. Then finally, this is also a very useful table. Finally, this is what's called all views, which is this particular full view in text. I don't ever use this one, but if you might. Back to our PowerPoint. So that's an example. US Core is a really good example, probably the most well-known example of all of the different profiles. But how do you actually, those are completed profiles, those are recognized profiles. How do you actually develop a profile? Let's look at an example. This example is ongoing, it's real. It's being developed by Krishna Juluru, who is a Johns Hopkins graduate, by the way. He is on loan to the White House Presidential Fellow Program from Memorial Sloan Kettering. The title is called At-Home COVID Test Reporting. And let's go ahead and click on this link. So you can see that this is Department of Health and Human Services. It's being developed through the National Institute of Health. They get published through ONC. You come down, and the first thing that you'll notice is a problem statement. The problem is that expand upon the notion that there's no focused guidance describing the use of HL7 standards, either version 2 or FHIR, to send at-home COVID test results to local, state, territorial, or federal health agencies. Talks about the goal in the audience, talks a little bit about the background, and here we have that the test results have value to the individual taking the test, but they also have value to the public health authorities responsible for coordinating a regional and national response to COVID. So it gives you the problem statement, and it gives you a little bit of background about why you actually want to do this and what you're trying to accomplish. We come down here to the workflow diagram, and it talks about, different people, different patients purchasing test strips from different companies. Here, company C, company D, they're using their mobile phones. They're going to upload them to an app server. By definition of them going through and hitting the send button, it is authorized by the individual. There's probably some additional small print text they need to read before they hit the send button. But we are using secure transportation, and we're using this particular profile as a data communication standard. This gets sent to a hub, which is also known as a FHIR database or FHIR repository. And in turn, there's an application which is connected to the FHIR repository, which is able to send the information out to a federal health authority and then multiple state health authorities. So this is an example of the thought process in stating the problem. One of the things that I like in here is that they go through and they describe the pros and cons of using HL7 version 2 and using FHIR and HL7 FHIR. If you recall, HL7 version 2 was developed in the early 1980s. It consists of hat and pipes and is a serial stream communication method. It's send only. There is no querying. Paul Nagi's slides had the luggable cell phones and the compact computer on this particular slide, if you recall that. It goes through and it talks about what we have to do with HL7 version 2. And then it comes down here and it talks about all the different parts of how FHIR can help. However, I love this statement. However, FHIR is not a magic bullet. And so it goes through and it talks about both the pros and the cons of using FHIR. The big con is that all of the state registries are implemented in HL7 version 2. However, there are systems which will translate between the two. Now let's go ahead and take a look at the FHIR reporting guideline. So this is the beginning of an implementation guide for FHIR, and they say that this is based on, you'll notice, US Core Diagnostic Report, as well as US Core Laboratory Result Observation. So they're going to start to build upon things that are already profiled to make yet another profile. So it's kind of profile layering, if you will. This is telling us that we're leaving the NIH site. That's important because we are now in a tool. This tool up here you can see is called Trifolia, and this is a tool which you can use to develop FHIR profiles. So you can go ahead and take a look through here. We go through the background information again. We go through some of the introductory material, and then this particular section I find to be kind of interesting, and it talks about the differences of US Core Laboratory Report and US Core Diagnostic Report profiles, and which ones we should use for this particular use case and why. So the next step for this in the development of this profile will be that they've picked, I believe it's the diagnostic report profile, and that they're going to build that out with the elements, and then they will get into the various cardinality and coded concepts. So let's jump back into our PowerPoint. A couple more topics. How do you document your profile? Several different ways. One is a capability statement. So this is the very first query that you did at the beginning of this class, was to query for a capability statement. It's the root, the endpoint / metadata as a search or as a get. And it returned a very large JSON object. So it's a machine readable JSON object and is at the system level. It tells you everything that that FHIR server can do. There's ways to constrain that, but the base one is at the system level. You can create a structured definition. A structured definition is also machine readable in JSON. However, you can use it to validate resources for your profile. And you create an implementation guide. An implementation guide is the human readable version of what your profile is actually doing. Finally, there's registries for all of these types of documents within HL7 so that you don't have to go searching an infinite number of websites. A couple more notes I just wanted to bring up. We discussed the profiling tools, there are all sorts of commercial development tools available to create these profiles. You do not need to create these pretty pictures. As a matter of fact, they have applications which will walk you through the process step by step of generating the profile, beginning with defining the use case. So these are commercial tools which typically have license fees associated with them, but I just wanted you to know that there's several which exist. One is called Forge. I believe Forge is by FHIR. There's another company called Trifolia, and there's several others as well. Another thing I just wanted to mention, there's a parameter which exists within FHIR called validate. So there's a way to validate a resource that a system is trying to create to make sure that it conforms with a certain profile. The format for that is post, the name of the resource, $ validate, and then validate against the profile. And here's the definition of the profile itself. In this case, the profile is called heart rate. Heart rate gives a certain line code, for example, to identify the systolic and diastolic, and uses certain measurements and encoded values. And so it will go through if you were to use this validate parameter against this resource, and it will not allow you to create a resource for heart rate, which does not follow the profile. Not all servers support the validation profile parameter. Takeaways. Define your use case well. Take your time to define your use case. Figure out which data that you need at the end. Your data that you need at the end of your use case should go back and define the data that you need at the beginning of the use case. Next step is to identify your FHIR resources to make sure to contain that data correctly. Once you're within your FHIR resource that you've identified, you can look at the elements, you can look at cardinality, you can look at the values, you can look at terminologies. It should be LOINC, SNOMED, ICD-10. If it's a condition, it's probably ICD-10. Do you need to use the extensions registry? The next step that you look at are there any particular API requirements that you need to say are required or should be supported? For example, are there any search parameters? What about modifiers? If you're looking at lab values, perhaps there's certain modifiers, greater than, equal to, less than, that maybe are optional according to FHIR, but there's something that for your particular use case, if a system wants to comply with your use case, you can put it in there to say that these types of modifiers are in fact required. You can define any expected outcomes or actions, and that would be in your implementation guide to say if once this is complete, this is the end state that we expect to be in. Finally, you need to document your profile through a capability statement, a structured definition, and an implementation guide, and put them into the proper registry. The takeaway is, if you want to use the data later, it is a really good idea to have that data on the inbound side accurate and profiled. And on that note, have a great day, and we will see you in class.